We will now move into our testing and validation section. So here we will study two main testing protocols that are the high-pot and the partial discharge methods. Then we will review also the emergency protocols and common mistakes. So let's start by the testing and validation protocols and why they are important. In high voltage systems, the integrity testing will play a very crucial role because it is the test that will ensure that the overall safety and reliability of the power system is ensured. The main goal of this testing is to confirm that all the high voltage components like the batteries, inverters and cables, as well as the high voltage protective materials that we are wearing, that all of those elements can handle the electrical stress that they will experience in real world conditions. It is not just about passing a standard test, it is also about identifying any early signs of insulation failures or potential faults that at the end could cause or could lead to electric shock hazards, to fires, or to vehicle malfunctioning. Think of it like through checkups that we are doing in our electric vehicle nervous system. If we skip these steps, we might miss some hidden problems that could surface at the worst possible time. Like on a busy highway or during a charging station. If we do not catch those high voltage integrity failures at time, that can lead to any dangerous situation, and finally that will scale up the problem. So these are the two methods that we will study. The first one is the high-pot testing. And let's start defining what it is. The high potential test, or also known as the dielectric withstand test, is the testing that measures whether the electrical component insulation can handle the voltage higher than the normal operating ratings or not. So essentially, during this testing, we will be deliberately stressing the insulation and checking if it will break down or if it allows any dangerous leakage of current. Why so important and why do we execute this testing is because in the case that if the insulation allows to pass higher voltage and has leakages in the insulation, it is likely to fail in an everyday operation, and we want to avoid that. The high-pot test is used in many fields, not only in electric vehicles. This is a test that is commonly used in consumer and electronics, in industrial equipment, and in the EV manufacturing industry as well. During this test, basically by applying a very high voltage, we get a clear pass or fail condition and an indicator that says if the insulator integrity is good enough or not. If there is a breakdown that occurs at this stage, it means that the component might be compromised, and that could lead to shock hazards, system malfunctioning, and the other problems that are associated. So this test is essential for electric vehicles for several reasons. One of those is the safety assurance. If the insulation fails under high stress, it can expose users to electric shocks or to the potential trigger of thermal events. During the test, the system passes, as you can see on the left figure, it passes when the leakage current that we measure after applying a high voltage in our insulators, when that leakage current remains below a certain threshold, often that is microamps or milliamps depending on the standards, in that case it will fail. It will pass. On the opposite side, the high-pot test will fail if the leakage current is higher and exceeds the limits of the testing protocol, and in that case, or also if we already have some arkings or breakdown or some electric shock being caused there. That is one of the reasons why the hypo test is very important in electric vehicles. The other one is the quality control. Electric manufacturers must comply with the insulation standards, and this test specifically confirms that the product meets the criteria and reflects that the brand reputation and the consumer trust is respected. And also this test is used to review and to have some preventive maintenance. So over time, because of vibrations, temperatures, moisture, and so on, the insulation might degrade. In those cases, this hypo test can catch early signs of deterioration and give us some insights of elevated leakage currents before we get to an actual problem and the problem scales into major failures. So by routinely performing this test and notice the pass and fail conditions, the technician can verify the robustness of the high voltage system. In that way, safeguard the drivers, reduce the likelihood of incidents, and ensure the quality of the insulations in our vehicle. In this slide, we are showing the typical testing procedure for HiPoT in an electric vehicles. And we start with the first step, that is the safety preparation. In that step, the first thing we have to do is to park the vehicle in a controlled area, disconnect the main power if possible, and to put any warning signs. In this case, in this step, the operator must be wearing the protective personal equipment, insulating gloves, footwear, and arc rating clothing as well. In the second step, then, we will have the test equipment set up. In that test, the high voltage electrodes will be connected to the battery or the inverter, while the ground electrode is placed in the chassis of the vehicle. Also, in that case, we choose between doing an AC or DC testing, depending on the standards that the manufacturer guidelines are using. And then we execute the test. The test requires to slowly ramp up the voltage to the specific level and to hold it at the maximum level, often for about 60 seconds. At that point, we have to watch that there are not leakages current, or that the leakage current stays below the certain threshold that the standard says, and that the insulation is in general in good shape. After that, we go to the next step, that is the fourth step, where we analyze the result. So in that case, the pass condition will be to have a low leakage current, to not have any arcing or sparkling, or to have any sign of deterioration in the insulation. After the test, then we discharge any stored energy, and we record the results, and we compare them with the standards that we are using, and the criteria that is establishing those standards is compared to the results that we obtain. Used correctly, this testing is very powerful for verifying the EV insulating performance, and also for giving everyone the peace of mind about the vehicle electrical integrity. Another test that we can use is the partial discharge testing. This is a technique that is also used in early detection of insulation degradation. What is the difference between the hypo test and the partial discharge test? Is the ability to detect tiny electrical discharges that make point out already very incipient faults that over long time and exposure can become catastrophic. So the partial discharge testing will measure those very small electrical discharges that might occur within a component insulation, and in these cases, unlike a full breakdown or a very high current that is flowing through the insulation, those discharges will not completely breach the conductors that we are testing. However, they are already warning signs that the insulation is not perfect and that it might fail in the future. The purpose of this test is then to identify those weak spots and those micro cracks or voids that with the traditional HIPO test we might not catch because they are very insignificant at this point. It is very necessary because over time and because of the repetitive activity that we are doing with the battery, those micro cracks or voids can lead to unexpected breakdowns. So this test can be applied in general to test individual parts or to test the entire system and to detect those failures early on. Based on these tests, we can, for instance, schedule maintenance or replace parts proactively, reducing the downtime of our system and lowering the long-term cost of it. When we think about the partial discharge testing, we can see it as a very detailed diagnostics that will listen all the whispers and all the possible troubles that the system may have before they become a full-blown and an important failure in our system. To continue, now let's discuss the emergency protocols. It is very important to know what to do if something goes wrong with an electric vehicle, even if all our safety measures and tests are done and we take all the precautions. We have to also know what happens if something fails. Responding to EV incidents without fire, to know how to handle EV incidents when there is a fire, and what are the special considerations that we have to consider in this type of accidents are going to be exposed in this section. Even when we do not have visible flames or fire in the incident that involves an electric vehicle, there is an important risk, and because of that we have to take specific measurements. So these are the different steps or considerations and recommendations in the protocol that we have to follow in case we are in the presence of an incident that do not involve fire yet. So the first thing that we have to consider is that we have to always assume that the high voltage is going to be energized. The battery can hold a full charge and thread every cable or every component as if it was live. It's very important to consider that before touching anything, because we assume, for instance, that the vehicle is not energized because it is turned off. That is a false assumption that we have should never take when we are attending an incident in an EV. The second thing is shock hazards. So when we are having shock hazards, when we are having incident involved with the EV and there is shock, there might be exposed wires, there are going to be damaged battery packs, and there are going to be maybe water infiltration that can create potential for electric shocks, and that has to be considered. Also, there might be also toxic and flammable gases that are going to be released. Those gases can occur if the battery is, for instance, venting or it is damaged. So in those cases, we have to wear the correct respiratory protection that might be needed. Also, we have to assume and to evaluate the severity of the physical damage. So a severely damaged high voltage system might release toxic vapors, short circuits, and all those can be delayed. So we have to approach very cautiously, even if the vehicle is not in it does not present fire right now. It doesn't mean that there is not gonna be a fire in the following seconds or minutes. Many of these reactions take time and they can be delayed, so we have to approach very cautiously to the vehicles. In all the cases, we have to follow the manufacturer emergency response guides. They often provide the vehicle-specific instructions for insulating the battery, for cutting the power, for securing also the general scene, and to know how to react. By treating every EV with respect during an incident, we keep both the responders and also the people that is around in a safe, we keep them safe. Now let's see what happens when we have an incident that is already involving an EV and there is already fire. When we arrive to the scene and there is the electric vehicle on fire, we have to remember always these key points. The first one is that water is generally safe, and using a water hose doesn't pose an electrocution hazard when it is used correctly. So in general, water is the best way to cool down a battery fire. That's the first thing that we have to remember. The second one is we have to avoid to use dry chemical extinguishers. These extinguishers are not going to be effective for lithium-ion batteries, and they can complicate even further the situation. The third one is that we never have to penetrate the high voltage battery. Attempting to open it, punctuate the battery, and trying to remove it or to force it somehow, at the end can escalate the thermal runaway and can cause even more dangerous gas venting and problems. And also we have again to consider that the vehicle is entirely energized, and to treat the vehicle and all its components, including the chassis, as if they were energized. Because of that, we have to always wear our personal protective equipment to prevent any shock on that. And finally, we also have to consider that the thermal runaway can last even for hours. So electrical vehicle batteries fires can reignite even after they have appeared out, and continuously cooling and monitoring is going to be vital. And we have to remain in the scene, keep the area safe, and be sure that the battery is going to be constantly being cooled down. There are some severe cases. The best approach may be in those cases just to let the battery burn in a controlled manner while we are protecting nearby areas, rather than risking the personal safety trying to extinguish it immediately. As always, we have to rely on the firefighters' protocols and the manufacturer guidance to know exactly how to react in each condition. Another type of accident that we may have with the vehicles is when it is submerged into water. For instance, this might happen after a flood, or if it is the vehicle is driven into a body of water. In such a cases, we have to treat it like any submerged vehicle, but to keep some points into consideration. The first one is that when we have a vehicle that is submerged, we have to always wear our protective equipment materials, including the rubber gloves, and if the footwear, our mask, and the full equipment there. We have to constantly monitoring signs of thermal runaway. We have to watch if, for instance, in the water there is bubbling, if we have smoke or we have gassing, that could indicate that there is a damage in the battery. We have to try to remove the vehicle from the water, and once you extract the vehicle, we have to follow the standard high voltage safety protocols, and to never assume that the battery is safe just because it is not underwater anymore. Also, after that, we have to do post-recovery monitoring. That means that we have to keep the vehicle under observation for at least few hours to spot if there is any delayed reaction, like possible ignitions, thermal runaways, or short circuits that can come afterwards. At least we have to monitor it during 1 hour, but even longer if it is necessary. It is important here to notice that while the water can short some components, the biggest risk is that the battery pack might still hold energy or to be partially compromised. And this can potentially spark ignitions once the battery is already out of the water. So a battery that has been submerged should not never be assumed to be working as normal. It has to be reviewed thoughtfully to guarantee that it is safe or not. Lastly, in this module, let's look at some common mistakes that are made by the technicians, by the operators, when they are dealing with the high voltage systems. Even if we have the best protocols and if we have the best equipment, all of those can fail if we have human errors in the process. So in the next slide, we will highlight the top errors that you can avoid easily if you pay enough attention to it. So here are some of the most frequent missteps that people make around the high voltage systems. The first one is underestimating it. And this is something that I have heard many times, is that it is just 120 volts. Even just 120 volts is gonna be deadly. Lower voltages might not kill you instantaneously as a high voltage, but you can still have serious injuries, and this can escalate into bigger problems. Also, skipping the maintenance is another common problem. Failing to inspect and to maintain the high voltage equipment is a problem because you assume that it is protecting you, but it actually invites to have unexpected breakdowns or arc flashes that you were not considering before. The maintenance of our equipment, it is important, and even more important it is to ignore the equipment at all. The gloves, the suits, the protective eyewear, the lifesaver, all of those equipments are there to help us, and skipping them can have devastating consequences. Another common problem is replacing the original fuses with cheap ones. When we are replacing the OEM fuse with a generic one, we might save a little bit of money in our system, but the reality is this can lead to other type of failures, and if it might, for instance, allow higher currents, and that can be fatal in some cases. And the last one is to work with live current and without the proper preparation. In general, we have to try to de-energize the system we are working on, and in case it is not possible to energize and that we are aware that we are going to be working on live current, we have to wear all the appropriate equipment and also to establish a safe area. So it's all about having consistent adherence to the procedures, to using the correct equipment, and to respecting the power of the electricity. By avoiding all of these common mistakes and to following the protocols and the recommendation, you will protect not only yourself, but also you will protect the people around you. With this, we conclude the fourth module of our high voltage and safety course. Thank you very much.